Hello, welcome. In this video, let us look at an example illustrating the Z transform of a mixed signal. That is, a signal that consists of a causal component and an anti-causal component. That is, given a signal x of n that is equal to a power n to u of n, that is the causal component, plus b power n into u of minus n minus 1, that is an anti-causal component. We want to find the Z transform of this signal. So to determine the Z transform, what we do is we break down the signal x of n as x1 of n plus x2 of n, where x1 of n is the causal component and x2 of n is the anti-causal component. So the Z transform x of z is given by x1 of z plus x2 of z. It is by using the linearity property of the Z transforms. X of z of the signal x of n is given by the sum of the Z transform of these two components, that is of the causal component and the anti-causal component. So x1 of z is the Z transform of x1 of n, that is summation n is equal to 0 to infinity a power n z power minus n, and which is obviously equal to 1 by 1 minus a z inverse from a previous video, and the ROC of this Z transform is the whole Z plane outside the circle of radius absolute value of A. So this is the Z transform of the causal component. Now for the anti-causal component, that is x2 of Z, is given by the summation n is equal to minus infinity to minus 1 b power n z power minus n. And we have learned that from a previous video, we have learned that the Z transform of minus b power n z u of minus n minus 1 is given by 1 by 1 minus b z inverse. So since we don't have a minus here, so there will be a minus here. That means the Z transform of b power n u of minus n minus 1 is basically minus of 1 by 1 minus b z inverse. And of course, the ROC is the region of bounded by a circle of radius absolute value of b. Now to find the overall Z transform, we combine them, that is we combine x1 of z and x2 of z, and the combination will be simply the sum of 1 by 1 minus a z inverse minus 1 by 1 minus b z inverse. And upon some simple algebra, we can easily show that this is equal to a minus b z inverse divided by 1 minus a plus b z inverse plus ab z power minus 2. So that is the overall Z transform. But the main question is, what is the corresponding ROC? So recall that for x1 of z, the ROC is absolute value of z greater than absolute value of a, and for the x2 of z, the ROC is a circle or a region bounded by a circle of radius b. Now to find the ROC of this combined signal, we have to find the intersection of these two regions. So for the first case, where the value of absolute value of A is less than absolute value of B, that means for the first signal, the ROC is given by, so the ROC for the x1 of z is given by the region outside the circle of radius A, or absolute value of A, and for the x2 of z, the ROC is given by a region inside the circle of radius. So for the condition where absolute value of A is less than absolute value of B, then the intersection between these two regions can be determined as, so in this case, the radius of the outer circle is absolute value of B, and since A is less than B, or the absolute value of A is less than absolute value of B, then there is a common region or intersection between these two ROCs, that is the ring-like structure, the ring-like surface between these two circles. Then this is the corresponding ROC. That means the ROC can be defined as absolute value of A less than absolute value of Z less than absolute value of B. So this ring-like structure is the ROC. But in the case where absolute value of A is greater than absolute value of B, then the intersection does not exist. That means the area outside the circle is given by this area, and the ROC for the second signal, that is x2 of Z, is in a region bounded by the circle of radius B, and this circle is inside the circle of radius A. So in that case, there will be no intersection between these two ROCs. In that case, there is no ROC. for the combined signal. So to summarize, for a given signal x of n, which is a combination of a causal signal and an anti-causal signal, the Z transform is defined by A minus B Z inverse by 1 minus A plus B Z inverse plus AB Z power minus 2, and the ROC exists only when absolute value of A is less than absolute value of B. That is the radius of the x1 of z, that is the radius of the circle corresponding to the ROC of the x1 of z is less than the radius of the circle corresponding to the ROC of the x2 of z, then only the combined ROC exists, and which is given basically by the ring-like structure between these two circles. And in the case where absolute value of A is greater than absolute value of A is greater than absolute value of B, then the radius of the first circle, that is for corresponding to the causal signal, is greater than the radius of the circle corresponding to the anti-causal signal. In that case, there is no common region or no intersection. In other words, the ROC does not exist. Thanks for watching.